व्यापिने शाश्वताय। के जिंदगी पथ है मंजिल की तरफ जाने का, के जिंदगी गीत है मस्ती से सदा गाने का, के मौत आराम से सो जाने की बदनामी है, जिंदगी नाम है तूफानों से टकराने का, के जिंदगी नाम है तूफानों से टकराने का। के मेरे देश में जने में बहादुर वीर, मेरे देश में जने में बहादुर वीर, मेरे देश में जने में बहादुर वीर। सुन के वीरों की कहानी, सुन के वीरों की कहानी, आए अमर सिंह शिवाजी वीर महाराणा,
अमर सिंह शिवाजी वीर महाराणा,
वीरता को उनकी जाने सारा जमाना,
वीरता को उनकी जाने सारा जमाना।
गजब था पृथ्वीराज का निशाना,
बंदी आँखों से कमाल दिखाना,
वो कमाल दिखाना। उसने बोल को पहचान करके मारा था तीर, उसने बोल को पहचान करके मारा था तीर। सुन के वीरों की कहानी, सुन के वीरों की कहानी, आए नैनों में नीर, मेरे देश में जने में बहादुर वीर, मेरे देश में जने में बहादुर वीर। सुन के वीरों की कहानी, सुन के वीरों की कहानी, आए नैनों में नीर, मेरे देश में जने में बहादुर वीर, मेरे देश में जने में बहादुर वीर। चंद्रशेखर उधम भगत लाजपत लाला,
चंद्रशेखर उत्तम भगत लाजपत लाला,
सुभाष चंद्र बोस वीर मतवाला,
सुभाष चंद्र बोस वीर मतवाला।
सूर्यास्तों को एक जगह कर डाला, सरदार पटेल जी का
ढंग निराला, कैसा ढंग निराला।
काटने आए थे वो भारत माता की जंजीर, सीने में हंस हंस के खाई।
गोलियां सीने में हंस हंस के खाई।
अंग्रेजों से लड़ी थी वह लक्ष्मीबाई, हार नहीं मानी अपनी जान
कमाई, उसने जान कमाई।
उसके मुंह में था लगाम, दोनों हाथों में शमशेर।
उसके मुंह में था लगाम, दोनों हाथों में शमशीर। सुन के वीरों की कहानी, सुन के वीरों की कहानी। आए नैनों में नीर, मेरे देश में जन्म में बहादुर वीर। मेरे देश में जन्म में बहादुर वीर। सुन के वीरों की कहानी, सुन के वीरों की कहानी। आए नैनों में नीर, मेरे देश में जन्म
में बहादुर
वीर। मेरे देश में जन्म में बहादुर वीर।
अंग्रेजों ने देश में जब करी मनमानी,
अंग्रेजों ने देश में जब करी गद्दारी।
देश लूटा दुखी किए हिंद के नर नारी।
देश लूटा दुखी किए हिंद के नर नारी।
ऐसे में आया था दया
खुला खुला लाइन बनाओ, खुला खुला लाइन बनाओ।
ऐसे में आया था
दयानंद ब्रह्मचारी। देश को दे गया
लाखों
क्रांतिकारी, लाखों क्रांतिकारी।
गुरु सुखपाल हरने आए भारत माता की वो पीर।
गुरु सुखपाल हरने आए भारत माता की वो वीर।
सुन के वीरों की जन में बहादुर वीर। मेरे देश में जन में बहादुर वीर।
बोले भारत माता की।
ये सारी चेयर इकट्ठी क्यों कर दी? रुको भाई, इस मेरे सामने वाले ब्लॉक में ये सारे लड़के खड़े हो जाएंगे। सरी सारे बॉयज खड़े हो जाओ, खड़े हो जाओ, ऊपर हाथ करो सभी। सारे के सारे खड़े हो जाओ, ऊपर हाथ करो, हाथ ऊपर करो जल्दी सारे। हैंड रेस, हैंड रेस सभी, सभी ऊपर हाथ करो। क्यों भाई, आपको हमेशा बोलते हैं चेहरे इकट्ठी मत करो, इकट्ठी मत करो, क्यों करते हो बार बार? हाथों पर करो सभी।
सुदेश,
चेयर को खुला रखो, आराम से बैठो, खुला खुला करो।
हेलो हेलो
बेटा गर्ल्स में ये सारे बच्चे उठ के आगे आ जाओ, इन चेयर को करो सारे, फटाफट आगे आओ, आगे तक बैठो सभी, कंप्लीट करो इसको, सारा कंप्लीट करो। ये कोई बीच में चेयर खाली नहीं छोड़नी है, इधर भी ये सारी चेयर कंप्लीट करो। जल्दी कीजिए, फटाफट कंप्लीट कीजिए, चेयर आगे आइए सभी।
हेलो हेलो,
बैठ जाइए।
आइए मेरे साथ गुनगुनाएंगे सभी छात्र। भारत माँ शेरों वाले है, भारत माँ शेरों वाले है, ओ शेरों वाली है भारत माँ, शेरों वाली है, ओ शेरों वाली है भारत माँ, शेरों वाली है। जिसके शेरों की दुनिया में,
जिसके शेरों की दुनिया में शान निराली है, भारत माँ शेरों वाली है, भारत माँ शेरों वाली है।
अरे शेरों
वाली है भारत माँ वीरों वाली है, मेरी माँ शेरों वाली है भारत।
जिसके शेरों की दुनिया में,
जिसके शेरों की दुनिया में शान निराली है, भारत माँ
शेरों वाली है।
है, भारत माँ शेरों वाली है।
शिवा प्रताप शेर नर, हिला दिए औरंग अकबर।
ओ शिवा प्रताप शेर नर, हिला दिए औरंग अकबर।
समर में चमका भाला, नाज था चेतक ऊपर।
ओ समर में चमका भाला, नाचता चेतक ऊपर।
वार नहीं जिसका झिला था, यवन मिट्टी में मिला था।
ओ वार नहीं जिसका झिला था, यवन मिट्टी में मिला था।
गरजता था पूना में, तख्त दिल्ली का हिला था।
ओ गरजता था पूना में, तख्त दिल्ली का हिला था। ओ
शिवा के जैसा आज नहीं, शिवा के
जैसा आज नहीं कोई बलशाली है, भारत माँ शेरों वाली है, भारत माँ शेरों वाली है। ओ शेरों वाली है, भारत माँ शेरों वाली है। जिसके शेरों की दुनिया में, जिसके शेरों की दुनिया में शान निराली है, भारत माँ शेरों वाली है, भारत माँ शेरों वाली है।
यहाँ हर रोज जवानी, नाम लेकर के कहानी।
ओ यहाँ हर रोज जवानी, नाम लेकर के कहानी।
सुनाती थी बच्चों को कभी काबुल की पठानी।
सुनाते थे बच्चों को कभी काबुल के पठानी।
जो सुत को रोता पाया, जरा भी शोर मचाया।
ओ जो सुत को रोता पाया, जरा भी शोर मचाया।
कहा चुप हो जा माने, हरि सिंह नलवाया।
ओ का चुप हो जा माने, हरि सिंह नलवाया।
सभी बच्चे ध्यान देंगे, ये जो बीच में वैकेंट चेयर है इस पर दूसरे बच्चे बैठिए जल्दी, कोई चेयर को खाली नहीं छोड़ेंगे। ये कोई डिसिप्लिन नहीं है कि एक बच्चा तो हमेशा आगे बैठता रहे दूसरा पीछे रहे। फटाफट सभी चेयर को कवर कीजिए। जिन लोगों ने फोटो ऑर्डर किए थे आपके सम्मान समारोह के, वो सभी अपने फ़ोटो ले सकते हैं, रसिक भाई के पास आए हुए हैं। और पीछे जो बच्चे बड़ा कंजस्टेड बैठते हैं, आप सभी आगे आएंगे। बॉयज़ में कोई भी कंजस्टेड नहीं बैठेंगे, आराम से बैठेंगे। आपके कार्यक्रम के जितने भी वीडियोस फोटोज़ होते हैं वो सभी रसिक भाई के पास साथ साथ मिल जाते हैं, आप उनसे ले सकते हैं। जितने भी सर्विसेज के लोगों के ग्रुप फोटोज़ हैं, इंडिविजुअल फ़ोटो हैं, आप सभी अपने ले सकते हैं। जितने भी पैरामिलिट्री फोर्सेस के लोग हैं वो ले सकते हैं सभी। इसके साथ मैंने आपको बार बार बोला, कोई भी बच्चे चेयर को उठाएंगे नहीं। बॉयज़ में बेटा आप सीटिंग अरेंजमेंट को डिस्टर्ब मत कीजिए, आप चेयर्स को रिप्लेस मत कीजिए।
ठीक है अच्छा। यहाँ हर रोज जवानी नाम लेकर के कहानी, यहाँ
हर रोज जवानी नाम लेकर के कहानी
सुनाती थी बच्चों को कभी काबुल की पठानी,
सुनाती थी बच्चों को कभी काबुल की पठानी।
जो सुत को रोता पाया जरा भी शोर मचाया,
वो जो सुध को रोता पाया जरा भी शोर मचाया।
कहा चुप हो जा माने हरि सिंह नलवाया,
ओ कहा चुप हो जा माने हरि सिंह नलवाया।
भाग उठारी दल कर में,
भाग उठार दल कर में जब तेल संभाली है भरत माँ शेरों वाली है, भरत माँ शेरों वाली है, शेरों वाली है, भरत माँ वीरों वाली है। इसके शेरों की दुनिया में, इसके शेरों की दुनिया में शान निराली है, भरत माँ शेरों वाली है, भरत माँ शेरों वाली है।
भावना उठी थी मन में, उठे थे शोले बदन में,
ओ भावना जगे थे मन में, उठे थे शोले बदन में।
नीच से बदला लेने गया ऊधम लंदन में,
ओ नीच से बदला लेने गया उधम लंदन में।
कि कस्टन हॉल में फायर गया मारा ओ डायर,
ओ कि कैस्टन हॉल में फायर गया हमारा डायर।
मचा एकदम हंगामा दैल गए सारे कायर,
ओ मचा एकदम हंगामा दहल गए सारे कायर। ओ
पेंटन विला जेल में हंसकर,
पेंटन विला जेल में हंसकर फांसी खा ली है, भरत माँ शेरों वाली है, भरत माँ शेरों वाली है,
ओ
शेरों वाली है, भरत माँ शेरों वाली है। जिसके शेरों की दुनिया में, इसके शेरों की दुनिया में शान निराली है, भरत माँ
शेरों वाली है, भरत माँ शेरों वाली है।
ओम। ये सभी स्टूडेंट्स आप ध्यान देंगे, राइट 5:30 पे वॉलीबॉल, बैडमिंटन और लॉन टेनिस आपके मैचेस होंगे। जैसे कल सर्विसेज की टीम के साथ हुए थे, पैरामिलिट्री फोर्सेस के जो टीम के पार्टिसिपेंट्स हैं आप सभी 5:15 पर ग्राउंड पर रिपोर्ट करेंगे। और सभी स्टूडेंट्स जैसे आप यहाँ से जाते हैं, आप सारी जिन जिन के पास बॉल्स हैं, अपनी बॉल, रैकेट्स और शटल सभी इक्विपमेंट्स लेकर आप कोर्ट में पहुँचेंगे। और पूरा का पूरा जितना भी आपका टाइम होगा, आप सभी अच्छे से सभी टीमों के साथ, सभी सैनिकों के साथ बड़े प्यार से और रिस्पेक्ट से आप गेम खेलेंगे। उस टाइम को आप कोई इधर उधर घूमने में नहीं लगाएंगे, आप रिस्पेक्टफुली स्पोर्ट्स करेंगे। इसके साथ साथ कोई भी टीचर्स, जहाँ तक कि आप हमारी आवाज़ सुन पा रहे हैं, कोई भी टीचर्स या स्टूडेंट्स रेजिडेंशियल एरिया में नहीं रुकेंगे, सभी मुख्य पंडाल में आएंगे। कोई भी लेट नहीं करेंगे, समय का ध्यान रखेंगे।
पढ़ो इतिहास पुराना, शेर था एक मर्दाना।
पढ़ो इतिहास पुराना, शेर था एक मर्दाना।
पढ़ो इतिहास पुराना,
शेर था एक मर्दाना।
खाट में वार की छानी,
नाम जिसका महाराणा। खाट में वाड़ की छानी, नाम जिसका महाराणा।
न वो बंधन में आया, न उसने शीश झुकाया।
न वो बंधन में आया, न उसने शीश झुकाया।
वीर धरती पर सोया, हाथ पर खाना खाया।
ओ वीर धरती पर सोया, हाथ पर खाना खाया। हो
घास की रोटी खाकर बेशक,
घास की रोटी खाकर बेशक उम्र बिता ली है। भारत माँ शेरों वाली है। भारत माँ शेरों वाली है। शेरों वाली है। भारत माँ वीरों वाली है। जिसके शेरों की दुनिया में, जिसके शेरों की दुनिया में शान निराली है। भारत माँ शेरों वाली है। भारत माँ शेरों वाली है।
रहे भयभीत फिरंगी, काप उठे लाट बिजंगी।
ओ रहे भयभीत फिरंगी, कांप गए लाट भुजंगी।
रोक ना पाई जिनको
कभी संगी ने नंगी, रोक ना पाई जिनको कभी संगी ने नंगी।
मिला हिटलर ने पना दी, जाओ जापान शला दी।
ओ मिला हिटलर ने बना दे, जाओ जापान सला दे।
कहा दो खून मुझे तुम, मैं दूंगा तुम्हें आजादी।
ओ कहा दो खून मुझे तुम, मैं दूंगा तुम्हें आजादी। हो
याद सभी को आज तलक,
यार सभी को आज तलक नेता बंगाली है। भारत माँ शेरों वाली है। भारत माँ शेरों वाली है। शेरों वाली है। भारत माँ वीरों वाली है। जिसके शेरों की दुनिया में, जिसके शेरों की दुनिया में शान निराली है। भारत माँ शेरों वाली है। ये बात है, भारत माँ शेरों वाली है।
बात ये नहीं आज की, भगत सुखदेव लाज की।
ओ बात ये नहीं आज की, भगत सुखदेव लाज की।
बात ये
नहीं आज की, भगत सुखदेव लाज की।
बिस्मिल से करने हिला दी ब्रिटिश राज की।
ओ नींव बिस्मिल से करने हिला दी ब्रिटिश राज की।
नीव बिस्मिल
से करने हिला दी ब्रिटिश राज की।
महात्मा तिलक सावरकर रहे जेलों के अंदर।
ओ महात्मा तिलक सावरकर रहे जेलों के अंदर।
ऋषिवर दयानंद ने सत्यार्थ प्रकाश को लिखकर।
और शेरों वाली है, भारत माँ शेरों वाली है, वो शेरों वाली है, भारत माँ शेरों वाली है। जिसके शेरों की दुनिया में, जिसके शेरों की दुनिया में शान निराली है, भारत माँ शेरों वाली है, भारत माँ शेरों वाली है, वो शेरों वाली है, भारत माँ शेरों वाली है।
बोलो भारत माता की।
हेलो, कुर्सी को उठाकर आगे नहीं जाना। कुछ चेयर लेफ्ट से ले लो, कुछ राइट से ले लो। खुला खुला उसी लाइन को पूरा कर दो। पहले आप समझो, देखो ये लाइन है, उधर चेयर ज्यादा है, इधर ज्यादा है। कुछ इधर से ले लो, कुछ उधर से ले लो, कवर हो जाएगी। आगे मत लेके आओ। लेफ्ट राइट में गैप कवर कीजिए, गैप कवर कीजिए। लेफ्ट राइट, आगे नहीं आना किसी को।
हेलो, बोलो स्वामी दयानंद सरस्वती महाराज की।
हारियों के तुम हो प्राण ऋषि, दयानंद तुम्हारा क्या कहना। हारियों के तुम हो प्राण ऋषि, दयानंद तुम्हारा क्या कहना। दयानंद तुम्हारा क्या कहना, ऋषिराज तुम्हारा क्या कहना। दयानंद तुम्हारा क्या कहना, ऋषिराज तुम्हारा क्या कहना। आर्यों के तुम हो प्राण ऋषि, दयानंद तुम्हारा क्या कहना। आर्यों के तुम हो प्राण ऋषि, दयानंद तुम्हारा क्या कहना। दयानंद तुम्हारा क्या कहना, ऋषिराज तुम्हारा क्या कहना। दयानंद तुम्हारा क्या कहना, ऋषिराज तुम्हारा क्या कहना। आर्यों के हम सब के हो प्राण ऋषि, दयानंद हमारा क्या कहना। आर्यों के तुम हो प्राण ऋषि।
ये मेरी आवाज पीछे तक आ रही है? ये पीछे वाले बच्चे हाथ खड़ा करें। ओके, आप लोग जो ये कथा शिविर में जितने आप लोगों ने अभी तक लेक्चर सुने, इतने सारे हिंदुस्तान के इतने महान पुरुष जो आपके लिए स्वामी जी ने इकट्ठे किए। सुप्रीम कोर्ट जस्टिस, गवर्नर साहब आज सुबह थे, आपके अपने प्रदेश के मिनिस्टर्स। तो मेरे हिसाब से आपने ध्यान से सुना है सबकी बातें, कुछ नोट्स बनाए हैं। कल टेस्ट होना है, रिटन टेस्ट। टॉप कौन करेगा उसमें? लड़कियां? लड़के करेंगे? लड़के तो बोले ही नहीं। हाँ, लड़कियां टॉप करेंगी कि लड़के? चलो गुड। तो अभी जो आपको इतना सारा सुनने को मिला, इतने बड़े बड़े लोगों से आपको दर्शन हुए, आपको मैं समझता हूँ आप इस बात से बिल्कुल निश्चिंत हो जाइए कि आप लोगों के जो भविष्य है वो अगर आप इसमें से सिर्फ 10% भी निकाल लेंगे तो आप सब बहुत सक्सेसफुल हो जाएंगे, बहुत सफलता हासिल करेंगे। ये मैं सही बोल रहा हूँ, गलत बोल रहा हूँ? गलत? ओके। तो अभी जो नेक्स्ट हमारे सामने स्पीकर आने वाले हैं, उससे पहले मैं आपसे दो एक सवाल करना चाहता हूँ। आई होप आपको पता है कि कितने तरह के इंजन होते हैं। इंजन समझते हैं? कार में इंजन कितने तरीके के इंजन होते हैं, कौन बताएगा? माइक दो यार, माइक इसको। कितने तरह के इंजन होते हैं? अरे तुम लोग अभी अभी तुमने भारत देश के सबसे प्रमुख वैज्ञानिकों को सुना है यहीं पे। सारे प्रमुख वैज्ञानिक स्वामी जी ने आप लोगों के लिए इकट्ठे किए, और आप लोग ये नहीं बता पा रहे हो कितने तरीके के इंजन होते हैं।
हेलो
हाँ क्या? इधर आके बताओ, कौन बता रहा है?
सर, there are mainly two types of engine: internal combustion engines and external combustion engine. In those there are also three categories basing on their fuel: petrol self combustion engines, diesel combustion engines, and CNG combustion engines.
Good,
Now we
bad,
have EVs
ठीक,
also. Thank you, sir.
तो जो ये दो इंजन इसने बताए हैं, इसमें से कौन सा इंजन लगता है इसमें जो गगनयान गया है, सॉरी चंद्रयान में कौन सा इंजन लगा है? अरे इधर आप मेरी बात सुनो ना, बगल में बात करोगे तो कुछ नहीं समझ में आएगा। चंद्रयान में कौन सा इंजन लगा है बताओ, आप बताओ ना।
Sir, external combustion engine.
नहीं बस, तुम नहीं, कोई और। चंद्रयान में कौन सा इंजन लगा है? नहीं पता किसी को? मारुति 800 का नहीं लगा है? हाँ बोलो, ये माइक पे बोलो, माइक पे। कौन सा?
साइक्रोजेनिक।
एक बार आराम से बोलो।
साइक्रोजेनिक।
क्रायोजेनिक बोलते हैं, सही बोला, बट क्रायोजेनिक बोलते हैं उसको। तो जो देश में, अब आपको एक छोटी सी कहानी बताता हूँ। क्रायोजेनिक इंजन का जो सबसे पहले जो डेवलपमेंट हुआ, वो वर्ल्ड में दो कंट्रीज़ ने, बड़ी जो कंट्रीज़ थी हमारी, उनने किया, यूएसए और यूएसएसआर। तो हमारे कुछ चुनिंदा साइंटिस्ट, चुनिंदा जो हमारे वैज्ञानिक थे, उनको देश ने चुना, और इन दो देशों से बातचीत हुई कि भाई ये इंजन हमें भी चाहिए, बिकॉज़ इस इंजन से जब आप स्पेस में जाएंगे तो यही इंजन ले जाता है, और कोई तरीका नहीं है इसमें जाने का। यहाँ पे जो दूसरे तीसरे दिन जो इंजन की वो मॉडल्स दिखाए थे, वो आप लोगों ने देखे थे? नहीं देखे थे, तभी तो पता नहीं है। तो जो ये आज से कम 22 साल पहले एक टीम गई थी इंडिया से, रशिया से, ये टेक्नोलॉजी लाने के लिए। तो उस टीम के जो हिस्सा थे वो अभी आपको ज्वाइन करेंगे। मैं उनके बारे में अभी और विस्तार में बताऊंगा। डॉक्टर वी नारायणन जो हैं इस टीम के हिस्सा थे, जो क्रायोजेनिक इंजन लेने गए थे, लेकिन वहाँ पहुँचने पे रशिया और अमेरिका एक हो गए और उनने कहा हम आपको ये इंजन नहीं देंगे। फिर उसके बाद हमारे देश के वैज्ञानिकों ने ये इंजन यहीं पे डेवलप किया, पूरा इंजन। ये बहुत ही काबिले तारीफ एक आविष्कार था, मेक इन इंडिया जिसको बोलते हैं। टोटली ये इंजन बना पाना, अभी दुनिया में मुश्किल से दो चार कंट्री हैं जो ये इंजन बनाते हैं। तो आपको इस बात का गर्व है कि आप लोग सब आपस में ही बात करते रहेंगे? ये जो है आपस की बातचीत आप बंद करेंगे तब मैं आपको कुछ और कहीं किसी से बात कराएंगे। मैं कुछ बात कर रहा हूं, आप लोग आपस में बात कर रहे हैं, तो आप आपस में बात कर लो। फिर आप प्लीज इधर देखो, मैं आपको बता रहा हूं ये देश का एक बहुत बड़ा काम है।
योर बैक शुड स्ट्रेट, सभी कमर सीधा करके बैठेंगे, बैक स्ट्रेट। सारे के सारे बच्चे, आपका आई कांटेक्ट मंच पे रहेगा। जो बच्चे पीछे बैठे हैं वो स्क्रीन को देखेंगे, कोई भी लेफ्ट राइट या नीचे नहीं देखेंगे, और साथ साथ आप लिखेंगे। सर प्लीज।
ओके। तो जो ये एक बहुत बड़ा गेम चेंजर था कि इंडिया के पास ये इंजन है आज, और जो अभी नेक्स्ट आएंगे डॉक्टर वी नारायणन, ये आपको बताएंगे कि कैसे वो गए, वहाँ पे मना हुआ। आज डॉक्टर वी नारायणन जो अब सुबह सोमनाथ सर आए थे, चंद्रयान के जो डायरेक्टर हैं, ये उनके साथ ही हैं और ये भी इनकी भी उतनी ही उपलब्धि हैं, ये साथ ही उनके रिसर्च में हैं। और जो अगला मिशन जो हमारा बहुत बड़ा मिशन गगनयान जाना है, जो ह्यूमन फ्लाइट जिसमें आदमी बैठ के जाएगा, वो सर करवाएंगे, इनके नेतृत्व में होगा, ये करवाएंगे सर। तो ये जो इतने बड़े बड़े लोगों से आपकी जो भेंट होती है, आप लोग इसको ज़रा ध्यान से सुने। आपस में बात करने का कोई फ़ायदा नहीं है, उसमें आपको कुछ नहीं मिलेगा। तो अभी मैं आपको हैंड ओवर करता हूँ डॉक्टर वी नारायणन को। आई होप आप लोग कुछ इससे ग्रहण करेंगे। ध्यान से सुनिए बातें, आपस में बातचीत बंद कर दीजिए। ओके सर, रिक्वेस्ट। ये बताना पड़ेगा कि ताली बजाएं प्लीज। थैंक यू सर।
ह्यूज राउंड अप्लॉज। आप जोरदार तालियां बजाएंगे।
सर, ओवर। Sir, we'll start with a video. Yeah, good afternoon to all of you. First, we'll start with a video. So you see the video of the Indian space program. Then I will come back and address you subsequently.
India has a rich cultural legacy. This ancient civilization had glimpses of many a genius. It is a blend of far and near, east and west, unique in many respects. It was also a powerhouse of science and technology. India finds its pride in its unmatched diversity of cultures, religions, languages, geography, climate, and people. The country has integrated everything into a magnificent blend. Its conquerors, its invaders, its rulers, its lords, its chieftains, and its people have cherished every bit of India, have merged into this superb piece of land. A unique model of oneness, of pride, of selfless belonging. People are its strength, its land and ocean are its wealth. This tiny peninsula boasts of its abundance of brains in every field, in every domain of knowledge. Still, its problems are plenty. Of unmatched complexity, of stupendous magnitude, problems of food, of shelter, of health, of sanitation, of education, and all to be resolved by itself. To be resolved through technology initiatives to touch their lives in every aspect, in agriculture, in communication, in drinking water, in land use, in transport. An invisible touch from a distance. ISRO touches the lives of every Indian from the sky, through its satellites, through its applications, through its technology, through its programs. The invisible hand knows no boundaries. Independent India saw a vibrant science program to make good for the lost centuries, to adapt itself into the new world of science and technology. In this multitude of science, a tiny rocket took off into the darkness of the sky with hopes of red flames. That was a splendid beginning, never to look back. The lashing waves of the Arabian Sea witnessed many more launches and uploaded with ecstasy. After the launch of foreign rockets, tiny rockets built in Tumba roared with amazing precision. Larger and mightier rockets replaced tiny Rohini-sounding rockets. Payloads grew in size, content and complexity. Launch vehicles emerged from the bays to conquer the sky. India accessed the rarest of rare space club with successful launch of SLV-3. Rocket testing payloads transformed into Aryabhatta, Bhaskara and Apple. The excitement of launching our satellites as others' payloads opened more challenges. Metal was cut for huge launchers to launch our satellites. The sky was no limit. Aerial remote sensing started with small aircrafts taken over by remote sensing satellites, and communication satellites established its space in the sky. The visionaries had drafted the program and commissioned to constantly endeavor in the years to come to provide the peaceful users of outer space for real problems of this nation. A test in the form of sight completed the triad of space systems: launch vehicles, satellites, and applications. The future was bright, technological possibilities immense, and challenges intense. Space applications should reign the program. The path was driven by need and vision, but laid with thorns of challenges. But resolute in missions, space service for every Indian. broadcasting, telecommunication, weather data collection, disaster mitigation, and many more, all combined into a single system to provide linkages between different facets of national development, the Indian National Satellite System. INSAT was commissioned in the early 80s. Later, the growth of similar projects was enviable. Natural resources are not forever. No harm to fragile Mother Earth. Natural resource management data with eyes in the sky. The Indian Remote Sensing Satellite System does that and much more. The largest constellation of civilian remote sensing satellites for cartography, resource mapping, and ocean studies in various spectral regions, even in cloudy weather. IRS provides precious data with sub-meter resolution for agriculture, water resources, forest, fishing, flood, and a host of other areas. The data for decision support, for forecasting, for planning, for mitigation, for mapping. The scanner satellites see all for the planners, for the people, for development, to reach out to meet the needs of the common man. Technology feats have emerged as world-class launch vehicles, the PSLV, GSLV, and GSLV Mark III. PSLV marks textbook precision in all its successively successful launches, continuous payload improvements. History marked by the successful launch of 104 satellites in a single mission. SRE-1 was a magnificent feat of recovering an orbiting capsule precisely and perfectly. Chandrayaan-1 was a national pride, giving the moon to every Indian in the first shot itself. Water on the moon is in the history of science, never to be overwritten. INSAT, the base platform for television broadcasting. The elite classrooms reaching thatched schools. Schools reaching living rooms. GSLV, the mighty launch vehicle with stronger muscles than PSLV, indigenously developed cryogenic technology. Mars Orbiter Mission Mangalyaan traveled beyond the blue sky to reach the ever-seducing red planet Mars. The first of its kind, marked by its amazing precision and cost-effectiveness. The successful launch of RLV-TD was a stepping stone towards the development of reusable launch vehicles. Air-breathing propulsion system that makes use of atmospheric oxygen as propellant. India's own space telescope, AstroSat, the milestones in the history of Indian space journey. GSLV Mark III, the one which can launch 4-ton satellite in geostationary transfer orbit and 10-ton satellite in low Earth orbit. The Giant, which operates with world's largest solid engine and own cryogenic engine, is a future hope of Indian space program. India's own navigation satellite system. That's not a dream, but a reality. IRNSS, NAVIC, paves the way for precise movement of every Indian. The virtues of Indian space program touch every Indian, day in and day out, with technology utilization in applications and services. Internet, telephone, banking, television, agriculture, water resource management, land utilization, town planning, transportation, navigation, telemedicine, disaster management, and whatnot. Miles to go before we reach. The destinations are ever expanding. Higher capacity communication satellites, capability for their indigenous launch. Scientific experiments that reach the sun or beyond. Science for space. Space for science. An Indian Vyomonaut orbiting the Earth in our own spaceship. It's not a distant dream, but at an arm's distance, the near future. Indian space program is continuing its glorious journey, overcoming all the challenges to more and more heights, fulfilling the golden dreams of its pioneer visionaries.
Five, four, three, two, one, zero. Plus 5 seconds.
Lift off normal, pivot tracking.
R2 tracking.
P2 tracking. Stage performance normal.
Congratulations, India. Chandrayaan 3 has started its journey towards moon. Our dear LVM-3 has already put Chandrayaan 3 craft into the precise orbit around Earth. 170 by 36,500 kilometers was its intended target orbit, and it is precisely there now.
It is a historical event for Indian space program and a proud moment for all the Indians across the globe on this momentous occasion of the successful launch of the Chandrayaan 3. The entire spacecraft community has put wholehearted effort during last 4 years, and we have realized a marvelous, great scientific satellite.
The Chandrayaan 3 spacecraft consists of a propulsion module and a lander module with a rover accommodated inside the lander. 6 modules were realized during Chandrayaan 3 project life cycle, out of which 3 were flight modules and 3 were special test modules. A test module called the ICT module was realized after integration, detailed IST, sensor level alignment and EMI/EMC tests were also carried out before shipment to ASTE Bangalore. At ASTE facility, the ICT module was integrated onto the helicopter in the underbelly cutout area, and this cutout acted as a viewport for all the sensors during the test. The helicopter was further ferried to Chitradurga, where the ICT tests were conducted in a campaign mode. A comprehensive module was realized for conducting the test by accommodating all essential systems. A new facility was realized at SDSC Shar for conducting the IHT, craters and boulders simulating hazards during landing. A total of 20 tests were successfully conducted, which include 6 dry runs, 8 static tests and 6 dynamic closed-loop tests. The lander leg drop tests were carried out to evaluate the energy absorption capability, strength and stability aspects of lander legs during touchdown on flat and sloped surface and on lunar soil simulant and hard surface. A total of 15 drop tests at simulator level and 2 drop tests at QM structure level were conducted successfully. Detailed assembled mode IST was carried out, followed by mass property measurement, thermo-vacuum test, solar panel assembly and illumination test, EMI-EMC test at CATF eyesight. This was followed by pre-dynamic deployment of secondary rover ramp, primary ramp and rover rollout from lander and payload deployments such as ILSA and Ramba, chased, and the lander was made ready for further activities. A 6-wheeled rover is accommodated inside the lander. Rover solar panel deployment and illumination test, rover standalone EMI-MC test, vibration test, thermo-vacuum test, and mass property measurements were carried out. All tests associated to rover were successfully completed and the rover was made ready for further integration onto lander. Chandrayaan-3 spacecraft was made ready for shipment to spaceport at SDSC Sharp.
Plus 5 seconds.
Lander module will get separated with a relative velocity of approximately 1 meter per second.
आप सबको सैल्यूट करना चाहता हूं।
7, 6, 5, 4, 3, 2, 1, 0.
TVD1 का सफलतापूर्ण प्रज्वलन स्थापन प्रथम प्रमोशन मंच से
Here we have a textbook liftoff of TVD1, a major milestone towards ISRO's Gaganyaan mission. Pillbox conditions will be achieved during the flight regime.
Engine thrust cut off, CES separated, HCM motors are ignited, grid vents deployed.
TVD1 को पृथक कर दिया गया है और CES, CM साथ में कोस्टिंग फेज में है। इस क्रम में अगली घटना CJM मोटर की फायरिंग के साथ क्रू मॉड्यूल को क्रू एस्केप सिस्टम से सेपरेट कर दिया गया है।
Now the crew escape system has been jettisoned. The apex cover has been jettisoned.
क्रू मॉड्यूल की गति को 152 मीटर प्रति सेकंड से 62.8 मीटर
Namaskar. Most respected and honorable Swamiji Dharmabhanuji, distinguished guests, outstanding personalities like Justice Swaminathan, Mr. Ramakrishna, and former district collectors, Brother, and so many outstanding personalities on the dais. My dear young children, colleagues, Namaskar. When India got independence in the year 1947, to be frank, I am not very confident in speaking continuously in Hindi, so I am going to English. When we got independence in the year 1947, India was really, truly an undeveloped country. We were importing in 1950s, we were importing food grains from other countries. And average life of Indian was just 32 years only compared to maybe 80, 90 years of developed nations. And you take any sector, education sector, rail transport, road transport, industries, health sector, everywhere we are really in a truly undeveloped country. Thanks to all the prime ministers of this country, including the present prime minister, the great person, Narendra Modi ji, they have taken India to greater and greater heights during the last 76 years. And you know, the father of the nation, Mahatma Gandhi ji, remarked, there is enough in this world for everyone's need, not for greed. That indicates the wholesome development requirement of the country. Our country had great legacy of scientific leaders. Jagadish Chandra Bose, who invented plants have feelings. He did microwave experiments. Sir C.V. Raman, who brought glory to the country by winning Nobel Prize for his work on scattering of light. The great mathematician Ramanujan, who discovered zero and brought glory to this country. And Swami Vivekananda and Tata together, when they discussed a great idea in the ship, which gave birth to the institute like IASC. And science and technology, the Homi Bhabha, father of Indian Atomic Energy Program. Vikram Sarabhai, the father of Indian Space Program, who who is a Indian, truly a Indian, and belongs to Gujarat state. APJ Abdul Kalam, Professor Satish Dhawan, Mr. Kurian, who brought white revolution, and Dr. Swaminathan, who brought green revolution. And today, India has developed in all sectors. If you take average life of Indians from 32 years, in 76 years of independence, it has gone to 71 years. And there were a lot of disease, smallpox, chickenpox, malaria, and our people are dying. Today, you know how we have handled under the leadership of our Prime Minister Narendra Modi ji, the COVID, how we have handled, that shows the testimony of the growth of the country. And every place we have grown, and every sector we have grown. And if you take one of the sectors, is the Indian space program. And 1947, we got independence. Next 15 years, there was no space program. The entire space program was started in the year 1962 by the father of Indian space program, Vikram S. Sarabhai, who strongly felt advanced technology can be used for the benefit of common man. From that humble beginning, today you have already seen, we have landed near South Pole, and India is the only country and the first country which has made that historical landing in the South Pole, and Indian flag is flying high and high compared to all other nations. And I am given 30 to 40 minutes time. In 30 to 40 minutes time, I will take the historical development of Indian space program, what is done and what we are going to do and which direction we are moving. That's what is my talk. Can you go to next slide? For the space, bringing space benefit to the common man, we need 3 areas of development. One is satellite development, second one is launch vehicles for placing the satellite, third one is infrastructure, ground infrastructure. My friend Ramakrishna is working in the third area. And I had the opportunity to work in the first 2 areas. Please. Now the entire activity started in Tumba, a fisherman village, in the year 1962. And 1963, we had the first launch, November 20th, 1963. 60 years of space program you have just celebrated. And the rocket came from Russia and the payload came from France, and we assembled in a church and we launched. And in 1967, November 20th, we had the first launch of a sounding rocket which was just 1 meter height, this much height, and 7 kg mass. Then the major milestone, 1980, we joined the elite group of nations by placing the first Rohini satellite, which is 40 kg satellite, by the SLV-3. The project director was none other than the People's President, APJ Abdul Kalam, and India joined the elite group of the spacefaring nations. From that humble beginning, we have moved a long way. We have developed 6 generations of launch vehicles. And the first launch vehicle was SLV-3, 1980, July 18. It was 17-ton mass. And the LVM-3 was launched in 2017 after 37 years. The mass has gone up 37 times. From 17 tons, it has gone to 642 tons, 37.7 tons. And the satellite mass has gone from 40 kg to 9,000 kg to low Earth orbit. And we have, in the satellite area, up to 1975, we were not having our own satellites. And we did the research in 1975. And the first project director was the Professor U.R. Rao. Under his leadership, the Aryabhatta satellite was built with the support of Russians, and it was launched by Russians. Almost 90% technology came from Russia. From that humble beginning, 1975, this country was not having satellite technology. Today, dear friends, we have conceived and built 125 numbers of satellites of various classes: communication, earth observation, navigation, experimental, scientific, and we have placed in orbit. And the small satellite is 40 kg, and the heaviest satellite is GSAT-11, around 6,000 kg. That is the growth of satellite technology. 1975, we were looking other countries. And when Modi ji took over as the Prime Minister of India, we conceived and built a 2,000 kg communication satellite and placed in the orbit using our launch vehicle and donated to SAARC countries. That is the type of development what has taken place in the satellite area. And you all please see this slide. The center shows the rocket what we developed in 1967, this much height. 1969, on the right side, you can see the rocket. 1969, I was in the first standard, sitting on the floor studying as a school boy. 1969, Neil Armstrong has landed on the moon, and we had this much height rocket. 1961, Yuri Gagarin has gone to space and come back. And you know, when we started our program, our rockets were tied on bicycles. Bicycles, not new, old bicycles, and we used to move. And the first satellite was moved in Bangalore for a test on bullock cart. On the right side you can see Kalavandi. And from that beginning, from that area, you please see where we have reached. 95, 3,987 rockets are launched from Indian soil, sounding rockets. 95 launch vehicles, 125 satellites of our satellites, 431 satellites of other country launched from India using our Indian vehicles. And so many applications. And if you look at the next slide, I have put the entire application which I can talk for 5 hours. There are 50 applications. Earth observation, satellite communication, Navy application, disaster warning and management, static application, so many applications. In the area of Earth observation, I can tell one application. India is having 7,500 kilometer seashore. Lot of our brothers are involved in the fishing. And there was a time people go and come back without anything. Today, through satellite, we inform the fisherman and they go and catch the fish in the right place and come. Through that alone, we are having a profit of something around 34,000 crore per year. And Indian ISRO's budget is only 14,000 crore per year. And take telecommunication. What is the revolution which has taken place 25 years back where we were standing? Television broadcasting. 25 years back, where was the television broadcasting? Today, where we stand. And disaster warning and management. Those days, if there is a flood or tsunami, thousands of our people used to die. Today, that is not the situation. We advance, we inform and save the people. And strategy sector, to monitor the borders, to monitor the ocean, lot of satellites, lot of applications we are doing. Truly, to understand the satellite applications, if we switch off the satellites evening 5 to 8 o'clock, there will not be no TV will work, no telephone will work, no warning will come, everything, no ATM, everything will come to a standstill. Now I am not going to dwell further on that. Now, coming to the PSLV, till today we have launched 59 vehicles and 57 are successful. That shows the reliability of that vehicle. And dear brothers, 60th vehicle, when we celebrate 60 years of Indian space program, we are going to launch on 1st of January 2024 from Sriharikota, 60th launch vehicle of PSLV. Till today it has placed something around 64 tons of payload. When we started with the humble beginning, we wanted to take leadership role. And in a single launch vehicle, Russia was the country which placed 37 satellites in a single launch vehicle. We set a target of making more than 100. India is the first country which placed successfully 104 satellites, more than 100 in a single go using a single rocket. That shows the growth of ISRO. And we had a space recovery experiment. First time a body was brought from the space to Earth. 2007, January 10, it was launched. January 22, it was brought down safely. And coming to the next slide, you can see the Chandrayaan-1 first interplanetary mission. India is the only country and first country which found, with the support of course, America, water molecules on moon and made all Indians proud. All Indians proud. We have also put the national flag, the tricolor on the moon through this mission. Next mission, the Mars orbiter mission. Hello, excuse me, please. Please see me and move. Mars orbiter mission. To red planet, 68 crore kilometers we have to travel. And India is the first country and only country which has successfully accomplished the Mars orbiter mission in the first attempt. None of the developed country has done it in the first attempt. And I salute our Prime Minister Ji, Narendra Modi Ji. He has done a simple calculation. The total expenditure what we have done, if you calculate per kilometer what is the expenditure, he has calculated it is less than auto fare. That shows the capability of Indians and Indian space program. And now PSLV, we are having the fourth stage as a experimental platform. Dear friends, any of you can bring the payloads. We are ready to launch on free of cost. You conceive the payload, we are free to launch. Any Indian citizen, students, college people, any ordinary citizen, we are ready to launch. When we celebrated 75 years of independence, we hoisted Indian national flag in space and we sent the Constitution of India through the communication link. That is the achievement through this mission. Now coming to the next vehicle, GSLV, which is double capability, and it has got lot of systems. And one of the important system is the cryogenic propulsion, where we use liquid hydrogen and liquid oxygen. Other than India, only 5 countries had this technology. We are looking other countries for the technology. Nobody was ready to share. Finally, it was Indians who took up as an indigenous development, and over a period of 20 years hard work, finally we have succeeded and we are having a propulsion system. And till today we have launched 10 indigenous cryo stages, and one more vehicle is going to have 9 stages. 10th stage is going to fly somewhere in January 2024. And you can see the development, lot of development. I think I can talk this separately on the cryogenic development, where we use extremely low temperature propellant. Liquid hydrogen minus 253 degrees centigrade, liquid oxygen minus 183 degrees centigrade. It is much lower temperature, very, very complex technology. Coming to the next vehicle, it's a historical development Mark III vehicle. And all new developments. Till today, 7 vehicles are launched, all are successful launches, including Chandrayaan 2, it has launched, Chandrayaan 3, it has launched, 2 commercial launches, it has successfully accomplished. Here, we have developed another cryogenic stage. Dear friends, we have made world history in the development. And from the engine test to the flight, India is the country which has taken the least time of 28 months, other than other countries have taken less time, is 42 months. And we have made world history, and we are having the technology in our hand. And a stage test, putting hydrogen and oxygen together. Hydrogen, if you handle, it will work as a fuel. If you don't handle, it will explode. And we set a target of doing a test in 30 days, 34 days against other countries of 10 months. And under the leadership of Kiran Kumar Ji, he was the chairman at that time. And today morning, Mr. Somnath was there. He was the director of LPSC. I was the project director. We 3 together decided to go for a test without any experiment. We have completed this experiment in 34 days against any other country which has taken 10 months minimum. And like that, we have made history. And coming to another mission, a KR mission, this is accomplished successfully. Next, due to geopolitical reason, thanks to our chairman, Mr. Somnath, he brought 2 commercial launches of Mark III. Please click. And 36 satellites in each launch we have to place in different places. It's a commercial launch. And unique way the mission was planned, and 2 vehicles, we have placed 72 satellites, and Indian flag is really flying high in the international arena. Today, including the developed countries, they want this vehicle service. Coming to the Chandrayaan 2, you all know, lot of mission objectives were there. First, we have to demonstrate the vehicle capability. Second, we have to place the Chandrayaan 2 in the required orbit of Chandrayaan in moon. Then, of course, soft landing. We could not accomplish the soft landing.
But I want to tell you one thing. There is an orbiter. That orbiter, the design life was 1 year. Because of our innovative management, the life has become 7 years. Give a big hand to people like people like Ramakrishna, who was handling this type of mission operation. Please give a big hand. And today the life is 7 years. And we are having an on-orbit camera called OHRC. The resolution is 30 centimeter, which is the best in the world in moon's orbit. And Indian payload is the best in the moon's orbit. And of course, we could not soft land. And a national level committee was constituted, with 9-member committee. With 1 month we have to study and submit the report. A 9-member committee really banned midnight oil, worked 24/7, and the committee submitted the report in exactly 30 days. And right now the project director has entered here, Mr. Veeramuthuvel, he has entered. He has really banned midnight oil to resolve this type of issues. And I happen to be the chairperson of the national committee which has submitted this report, and I think give a big hand to Mr. Veeramuthuvel and his team, who has really done lot of work for resolving the issues. And finally, we have realized a beautiful satellite, Chandrayaan 3, 3,900 kg satellite, with implementing lot of recommendation, lot of testing. And I think this team, with Veeramuthuvel as the project director and so many project executives, and under the guidance of chairman and all directors, so many tests were done, and today it is a history. I am not going to dwell. I will leave it the stage to him later to present. Please go to the next slide. And the vehicle has placed the satellite in the required orbit. We are supposed to place the satellite in the required orbit with 170 km by 36,500 km plus minus 500 km. Only 10 km was the difference. This is the best performance any vehicle can give in a world of that class. Second, we have taken it to the moon. I think you move. We have taken it to the moon, and it was perfectly captured. And so much work was done. In almost 40, 45 days, sleepless night was spent by Indian scientists, thousands of people. And finally, it is a world history. On 23rd August 2023, the Chandrayaan 3 was rotating with 6,077 km per hour, which was brought to rest in 19 minutes by traveling 750 kilometers. And Indians are famous for discovering the zero and making India proud. And here 3 parameters simultaneously we made zero, and we have put the Indian flag above the flag of all other countries in the world, and India has made history. And of course, through this mission, lot of achievements were made. I will not dwell on that. Please move. And I think I will leave the stage to Veeramuthuvel and Ramakrishna. Please move to next slide. And one of the important achievement is, India is having so many religion, and different types of people. 140 crore people. This Chandrayaan 3 program has integrated as a single country. That is one of the major achievements. And we have made scientific number in the country, not only among students, the entire community of people. Please move. Please move. And of course, we have also done a couple of important experiments. Please move the slide. And lot of discoveries. I will not dwell. Let Veeramuthuvel address that. All the 6 payloads have done excellent discovery, and we have donated the scientific data to the scientific community of the world. And another 2 important experiment what is done is, this lander was lifted and once again placed back safely. This was one of the experiments, and that is also brought back to the Earth orbit. These are the 2 important experiments further carried out. Thereby, the original objective of Chandrayaan 3, in my opinion, is achieved with 60% of the allotted budget. Next slides. And next thing is the Aditya L1 mission. And India has realized a 1,400 kg, 480 kg Aditya satellite. And India is the 4th country which has realized a satellite for studying sun. And it is perfectly launched by PSLV vehicle. And we have to travel almost 15 lakh kilometers. Right now the satellite is going near to the required place of L1 point. And January 6th or 7th, we are going to commission the satellite. Thereby, dear friends, India is going to make another history by commissioning Aditya L1. Thereby, India will be the one among fourth country to have such a satellite. We are going to have a history on January 1st week. Coming to the next important missions, the human spaceflight mission. Right now, having successfully accomplished Chandrayaan 3, Aditya L1, almost near success, we are working on Gaganyaan program for taking Indians to space and bringing them back safely. Towards that, lot of development works are going on, including propulsion, environmental control system, mission management, lot of works are going on. And recently we have done another important experiment. Go to next slide. Whenever human beings are there, if there is an unsafe situation, they have to be saved. They have to escape. We have a crew escape experiment which was recently done very successfully. The photograph shows that experiment. And the crew module was aborted after taking to some altitude. Safely it was landing in the sea and we have recovered. You can see the next photograph, the module which was recovered from the sea. As new module, it was recovered. And now, maybe in another 1 or 2 years, we are going to have our human spaceflight program. Lot of experiment has to be done. Now we are working on improving the Mark III capability. Towards that, we are developing new propulsion systems, including liquid oxygen and kerosene rocket engine systems. And next development, right now our capability of our vehicle is maximum 8,500 kg to low Earth orbit. We are going to develop a new vehicle. I think Chairman ISRO, Mr. Somnath ji would have morning told. A new generation vehicle is under configuration study, which will have double capability. For that, a liquid oxygen and methane engine system is being developed in Liquid Propulsion System Center. And we are also working on reusable launch vehicle system. Towards that, lot of experiments are getting executed in Indian space research organizations. And air breathing propulsion. You know, lighting a lamp itself is very difficult. But here, air will enter with high Mach number. And under that situation, we have to ignite and sustain the ignition and generate the thrust. That experiments are going on. And next important thing, couple of experiments are going on for vertical recovery. And satellite, you know, Chandrayaan 3 satellite, out of 3,900 kg, 2,500 kg was chemical propellant. If we can have better propulsion system with better efficiency, this mass can be brought down and useful payload can be improved. We are developing electric propulsion. The efficiency of that propulsion system is 3 to 4 times of chemical propulsion. Therefore, this we are going to launch in coming July. And space economy is one of the area Honorable Prime Minister has shown the way we are concentrating. Right now, our share is hardly less than 2%. And through the space sector reform and in-space system, we are going to target more than 8% space economy in another 10 years. And lot of new programs are there. There is a beautiful satellite called NASA ISRO Synthetic Aperture Satellite, which is jointly developed. It's the costliest satellite ever realized in the world, which is built in ISRO facilities in Bangalore. And we are going to have such a beautiful launch combinedly. And we are going to have a XPOSat, X-ray polarimetric satellite launch, very near. And we are planning to have lot of programs. The Gaganyaan program. And we are going to have a second launch pad in Kulasegarapattanam. And Samudrayaan program, which is the responsibility of Earth Science Department, but we have got great contribution towards that. And, you know, recently our Honorable Prime Minister has given a roadmap what ISRO should do or India should do. Of course, lot of satellites we have to build and launch. Our neighbors last year for strategic application, they have launched 100 satellites. That shows how much we have to launch and what we have to do. And today, every department needs satellites. So 500 or, I don't know, more number of satellites are required. That we have to realize and launch. And 2025 we will have our own Indian will be taken by our own vehicle, and we are targeting to bring back. That is targeted 2025. That is the target we have put. And we are planning to have a space sample return moon mission in 2026. And 2035 there will be Indian space station. Dear friends, when we started our space program, we were 60 years behind. Couple of places we have reached and we have matched international community. Some places we have superseded them. But there are places we are behind. By 2035, 2040, we will be in par with the international spacefaring nation in all fields in terms of capability, capacity, and all capabilities will be in par. And 2040, we will have Indian landing on moon, and he or she will be safely returned back. And I can go on talking. I want to stop with this last slide. We are having a strong vision to take the Indian space program forward, match with any other spacefaring nation. We are not competing with anybody else. Till today, we were developing all the systems for meeting the common man requirements. But today, the demands are different. Capability requirements are different. We are having clear roadmap to match that capability. Thereby, dear friends, dear students, you all have got great chance to contribute for making this country as a developed country. Really, if you look at this country, today, yes, we are self-sufficiency in food production, but the type of adulteration in the food, we have to come out of that to make us India as a developed country. Yes, we are having lot of trains, but then we have to track entire systems. Today, out of 8,000, 2,800 trains only we are tracking. And we have to ensure the safety of all citizens. Means we have to have number of satellites, number of systems in the border. When we celebrate 100 years of independence, when we got independence 1947, our average life was 31 years, 32 years. Today, in 76 years of independence, it has become 71 years. This number has to become 100 years when we celebrate 100 years of independence. And we have to have clean water, clean environment. Today, the pollution, we are controlled by pollution. And we have to have lot of things, lot of infrastructure. Towards that, you youngsters have to contribute a big way. I don't have any doubt. The Indians are excellent, outstanding, smart, dedicated, and with the younger generation rising and contributing, surely India will become a developed country, and developed country before we celebrate 100 years of independence. I wish to thank the organizers for giving us the great opportunity for me, our chairman, and all ISRO colleagues to participate in this wonderful program and say a couple of views. Thank you. Jai Hind.
आगे का समय इसी को चालू रखेंगे हम। तो मैं रिक्वेस्ट करूंगा चंद्रयान 3 के डायरेक्टर साहब वो यहाँ पे आके आपको पूरा डिटेल में समझाएं जिससे इसकी कंटिन्यूटी बनी रहे। सर प्लीज। हाँ आप प्लीज इंट्रोड्यूस योरसेल्फ। ओके हाँ प्रेजेंट कर दीजिए। ये देना है। आप बता दीजिए। आप बता दीजिए सर, आप बता दीजिए।
Okay. But I will speak. I think we will request Ramakrishna sir to introduce in Hindi. That will be appropriate.
Okay, ठीक है।
Sir, introduce.
वो PowerPoint लोड होगा। आप यूज कर दो इनके साथ।
So use it. I will, and then you take next. मेरा जो है ना
सबको नमस्कार. The great person, Sri Dharmabuddhi ji, who has really made this Rashtrakatha Shibir सब लोग को इधर सभी क्षेत्र से भारत का सभी स्टेट से सब लोग इधर आया है. सबको शुभकामना. और गण्य व्यक्ति जो उपस्थित है उन लोगों को शुभकामना है. मैं थोड़ा करने के लिए प्रयास करूंगा क्योंकि हम लोग हमारा रोज काम जो कर रहा है अंग्रेजी में कर रहा है, इसलिए बहुत थोड़ा मुश्किल होगा, लेकिन प्रयास करूंगा. हमारा पहली स्पीकर डॉक्टर नारायणन जी स्पेस के बारे में इतना बोला. स्पेस का उपयोग क्या क्या होता है, कैसे कैसे कर सकता है, बहुत अच्छी से बात किया. और इंडियन स्पेस प्रोग्राम के बारे में हम जो छोटी सी रॉकेट 1967 में साइकिल के ऊपर लेके जा रहा था, उस समय से आज तक कैसे इतना डेवलपमेंट किया, इसके बारे में बहुत अच्छी बात किया. ये रॉकेट क्यों चाहिए, ये सैटेलाइट क्या है, इसके बारे में मैं थोड़ा बात करूंगा क्योंकि स्पेस एप्लीकेशन के बारे में नारायण जी ने बहुत बोला है, आप सबको पता ही होगा. आजकल हमारा जीवन में स्पेस के बिना नहीं रह सकता, मतलब सैटेलाइट के बिना, क्योंकि हमारा रोज हमारा सब काम में कहीं ना कहीं सैटेलाइट का उपयोग हो रहा है. क्यों हो रहा है, ये सैटेलाइट क्या है पता नहीं. आप लोग अपनी पुस्तक में पढ़ा हुआ, लेकिन मून एक सैटेलाइट है. मून मोर देन 600 मिलियन और हंड्रेड्स ऑफ मिलियंस ऑफ ईयर्स वो उधर है, लेकिन उसको उपयोग हम लोग कुछ नहीं किया. हम उसके बारे में कविता लिखा है, उसके बारे में उसको डिस्क्रिप्शन कर रहा है, उसके बारे में ये होता है वो होता है बोल के कुछ लिखा है. ये मून एक सैटेलाइट है, नेचुरल सैटेलाइट है. आप सबको पता है मून 28 डेज भूमि के कक्ष में जाएगा और अपने आप 28 डेज अपने आप रोटेट कर रहा है. जैसे भूमि सूर्य के कक्ष में 365 डेज एक साल ले रहा है और अपने इसमें 24 आवर्स ले रहा है. लेकिन चंद्रमा ने 28 डेज दोनों तरफ से ले रहा है. लेकिन ये नेचुरल सैटेलाइट से हमको कुछ नहीं हुआ. सो ये आर्टिफिशियल सैटेलाइट क्यों चाहिए. सैटेलाइट जो स्पेस में होगा, आपको एक एग्जांपल देता हूँ. सैटेलाइट एक टॉर्च लाइट समझिए. टॉर्च लाइट जो आप नज़दीक में लिया तो उसका लाइट छोटी सी जगह में फॉल होगा, ऊपर लिया तो वो बढ़ती जा रहा होगा. मतलब इसका क्या मीनिंग, ये सैटेलाइट स्पेस में हुआ तो बहुत जगह कवर कर सकता है. आपको समझ में होगा जो कम्युनिकेशन सैटेलाइट हम 36,000 किलोमीटर में रखा जा रहा है, क्योंकि वहाँ पर सैटेलाइट स्पीड और हमारा भूमि का रोटेशन स्पीड दोनों एक ही होगा. मतलब सैटेलाइट भूमि के कक्ष में 24 आवर्स में एक ऑर्बिट कंप्लीट करेगा। मतलब आप समझिए 2 बस एक ही स्पीड में जा रहा है, एक बस से दूसरी बस आप देखा तो वो स्टेशनरी रहेगा, वो उधर ही खड़े हुए ऐसी लगता है आपको। वही प्रिंसिपल है हमारा जियो स्टेशनरी सैटेलाइट का। ऐसा तरफ सैटेलाइट हम टीवी, कम्युनिकेशन और डिजास्टर मॉनिटरिंग ये सब के लिए यूज़ कर सकता है। दूसरा लो अर्थ ऑर्बिट सैटेलाइट है, जो वो कक्ष, उसका कक्ष कम होगा, मतलब वो 500 या 600 किलोमीटर के दूर के ऊपर होगा। उसके प्लेटफॉर्म में अच्छी सी पावरफुल कैमरा हो और कम्युनिकेशन होगा। सो ये भूमि का सब पिक्चर लेते हुए वो पिक्चर से हम लोग बहुत सारी सकता है, इसको बोलता है रिमोट सेंसिंग। ये एक ऑर्बिट ये 100 मिनट्स में कंप्लीट करता है। इसी सैटेलाइट्स पूरा विश्व को कवर कर सकता है। हमारे पास जो ओशनोग्राफिक सैटेलाइट्स है वो 2 दिन में पूरा विश्व को कवर कर सकता है। रिसोर्स सैटेलाइट्स है 24 डेज में पूरा विश्व को कवर कर सकता है। ये क्यों कवर करना है, क्या करना है? क्योंकि हमारा पूरा ग्लोब में क्या हो रहा है, क्या क्या क्रॉप्स ग्रो हो रहा है, और हाउ इज ओशन, विंड, all these parameters we can study. ये सैटेलाइट ऑर्बिट में कैसे रहता है? सुना रॉकेट लेके जा रहा है सैटेलाइट को। रॉकेट क्यों चाहिए? आपको एक एग्जाम्पल बोलता हूँ, आप पढ़ा ही होगा। एक पत्थर आप फेंके तो ये ट्रैजेक्टरी में जाके नीचे गिर जाता है, थोड़ा और फोर्स दिया तो थोड़ा दूर जाता है। आप थोड़ा और फोर्स दीजिए, थोड़ा और दूर जाएगा, और इतना फोर्स देना है वो गिरा नहीं है, वो पूरा भूमि को ऑर्बिट करेगा। यही प्रिंसिपल है जो रॉकेट करता है। रॉकेट इतना फोर्स देना है जो सैटेलाइट नहीं नीचे गिरना है। मतलब जो 500 किलोमीटर में मैं ऑर्बिट में रहना चाहता हूँ, हमको 7.5 किलोमीटर पर सेकेंड उतना वेलोसिटी चाहिए। ये वेलोसिटी हमारा रॉकेट PSLV, GSLV, ये सब जो नारायणन जी, ये वेलोसिटी रॉकेट से मिलता है। रॉकेट में स्टेजेस बनाता है। क्यों बनाता है? क्योंकि इतना मास हम भूमि के गुरुत्वाकर्षण से लेना पड़ता है। गुरुत्वाकर्षण आपको पता ही है, बहुत है। आपको न्यूटन्स लॉ ऑफ ग्रेविटेशन सब पता है, आप अपनी क्लास में पढ़ा ही होगा। मतलब 2 मास ये सैटेलाइट मास ज़्यादा है तो हमारा रॉकेट ज़्यादा फोर्स देना पड़ता है। न्यूटन्स लॉस ऑफ मोशन आप पढ़ा ही होगा अपना स्कूल पे। उसमें F = ma बोलता है, मास इंटू एक्सेलरेशन। मतलब जितना मास है उतना एक्सेलरेशन और फोर्स भी देना पड़ता है। ये जो आप अपनी क्लास में जो पढ़ रहा है साइंस में, ये बहुत इम्पॉर्टेंट है, क्योंकि ये सब प्रिंसिपल्स, ये सब लॉस जो है वो सब हम लोग यूज़ कर रहा है अपनी स्पेस रिसर्च में। ये सब फिज़िक्स जो पढ़ रहा है बहुत बहुत इम्पॉर्टेंट है। आप अपनी क्लास में जो पढ़ रहा हूँ, पढ़ाती रहे हूँ, वो सब अच्छी सी पढ़िए और ये सब अच्छी सी सीख ली है, क्योंकि ये बहुत इम्पॉर्टेंट है हमारा स्पेस साइंस में। आप अपना आकाश देख रहा हूँ, वो ब्लू कलर है, लेकिन स्पेस में गया तो वो उधर ब्लैक दिखा रहा है। मतलब क्या है? उधर कुछ नहीं है, नो एटमॉस्फेयर, देर इज नो रिफ्रैक्शन, लाइट रिफ्रैक्शन डजंट हैपन, सो इट इज ब्लैक। मतलब उधर वैक्यूम है। हम लोग गगनयान के बारे में बहुत सारी बात किया। गगनयान में क्या कर रहा है, क्या चैलेंजेस है? पहला चैलेंज है ऐसी एनवायरनमेंट क्रिएट करना जो एस्ट्रोनॉट्स वो क्रू मॉड्यूल में जा रहा है, उसके लिए अच्छी सी ऑक्सीजन, नाइट्रोजन जो अपनी एटमॉस्फेयर में है वो सब चाहिए। वो कैसे क्रिएट करना है, ये सब बहुत मुश्किल है स्पेस में करना, क्योंकि उधर ऑक्सीजन नहीं है। ये सब रिसर्च करते करते इंडियन स्पेस रिसर्च ऑर्गेनाइजेशन जो डेवलप कर रहा है गगनयान का, ये सब इंस्ट्रूमेंट्स डेवलप कर रहा है। आप लोग जो पढ़ रहा है अपनी क्लास में 7th, 8th, 9th, इवन 10th और 11th, जो मैथमेटिक्स पढ़ रहा है वो सब बहुत इम्पॉर्टेंट है। जो आज डिफरेंशियल इक्वेशन पढ़ा हुआ, पार्शियल डिफरेंशियल इक्वेशन होगा, इंटीग्रेशन होगा, ये सब हम लोग रोज़ हमारा काम पे यूज़ करता है। और एक बात आपसे शेयर करना चाहता हूँ, जो हमारा वैदिक साइंस है वो भी बहुत इम्पॉर्टेंट है। जो वेदास में लिखा हुआ है वो आजकल हम डिस्कवर कर रहा है। वेदा एंड साइंस दे आर बहुत क्लोजली रिलेटेड। वेदा और साइंस दे डोंट कॉन्ट्रडिक्ट, और वो जो वेदा में है वो डायरेक्टली आपको समझ में नहीं आता है क्या लिखा है बोल के, क्योंकि वो सब संस्कृत में होगा और लैंग्वेज का प्रॉब्लम होगा। लेकिन वो किसके बारे में बात कर रहा है बोल के आपको समझ में नहीं आएगा। लेकिन आजकल बहुत रिसर्च कर रहा है वेदा एंड साइंस, हाउ दे आर रिलेटेड। हमारा पुराना साइंटिस्ट लोग, बहुत सारे लोग लाइक केपलर, गैलीलियो, ये सब लोग वेदा भी पढ़ा था थोड़ा सी, और वो साइंस में यूज़ किया। इसलिए ये लोग बहुत सारी डिस्कवरी किया और बहुत इसके बारे में रिजल्ट्स बताया। मैं एक सिंपल टेक्स्ट पढ़ता हूँ। हमारा ऋग्वेद में लिखा है, द सन हैज़ टाइड अर्थ एंड अदर प्लैनेट्स थ्रू अट्रैक्शन एंड मूव्स देम अराउंड इटसेल्फ as if a trainer moves newly trained horses around itself holding their reins. आप देखा होगा एक पिक्चर जो सूर्य का सामने अश्व का, बहुत सारी अश्व होगा और एक रथ होगा, उसमें सूर्य होगा, और ऐसी पिक्चर आप देखा होगा कहीं पर। लेकिन इसको क्या अर्थ बनाता है? These horses are planets. The reins which are holding the horses are nothing but the gravitation from sun to these planets, and the force which is pulling is holding the horses in such a way that it goes around the sun. ऐसी बहुत सारी एग्जाम्पल्स मैं आई कैन गिव। हम जो साइंस के बारे में बात किया और वेदा का भी बात किया। आप जो वेदा और साइंस जो पढ़ रहे हैं, वैदिक साइंस, आप अच्छी सी रिलेट कीजिए साइंस में क्या मीनिंग आता है, और इस बारे में आप जो रिसर्च करता है, लेकिन लेटर पॉइंट ऑफ लाइफ हम गारंटी करता है आप बहुत बड़ा साइंटिस्ट भी बन सकता है। ये 2-3 बात आपसे शेयर किया। आप अच्छी सी पढ़ाइए अपनी तरगति में, और साइंस और मैथ्स का पूरा पढ़ाइए। हम आप सब लोग को बेस्ट ऑफ लक बोल के थैंक यू, जय हिंद, and I thank the organizers for giving me this time to share my thoughts. Thank you.
अब मैं प्रोजेक्ट डायरेक्टर चंद्रयान 3 डॉक्टर वीर मुथुवेलु को इनवाइट करता हूँ यहाँ पे आके अपने विचार बच्चों को समझाएं और चंद्रयान 3 के बारे में पूरी उसकी रोचक कहानी से सबको अवगत करें।
Respected Swami Dharmabandhuji and all the dignitaries on the dais, I am very happy to share with all the dignitaries in the dais, and it is very tough for me to present as the previous speakers spoke very well, and distinguished invitees who are part of this event, and thank you very much for inviting me to be part of this event. Most importantly, my dear students, good evening to all of you. I will cover the Chandrayaan 3, even though Narayanan sir has spoke about Chandrayaan 3, but I will concentrate more on Chandrayaan 3. If any questions are there, I would like to answer. Next slide. So, as you all know that there are 4 countries have landed onto the moon successfully. Started with USA. They initially had Surveyor Apollo missions, and previous to Surveyor there were Ranger missions. It was largely unsuccessful, and they had a Surveyor which is an uncrewed mission, and Apollo was a crewed mission. And USSR also has got a Luna program. There are series of Luna which landed on the moon successfully, and China also has got a Changi mission. And India also started with the orbiting mission. Primarily that was a Chandrayaan 1 mission, and Chandrayaan 2 was having an objective of orbiting as well as landing. So we know that the landing was not successful in Chandrayaan 2, even though the orbiter is functioning well. The Chandrayaan 3 was very successful. We met the objective of landing near to the South Pole. We were the first country to land near to the South Pole, as you all know. Next slide. So, before India, as I told, 3 countries, before the first successful attempt, US had 3 unsuccessful attempts. USSR also had 11 unsuccessful attempts, and Chandrayaan 2 also was an unsuccessful attempt. And recently there were many unsuccessful attempts. So Bearsheet by Israel, Akuta R1 mission by Japanese, and Luna 25 just before our landing also was Luna 25 was aimed to have a landing near to our landing site, but they could not achieve the mission objective. Hence, the lunar landing missions are very complex in nature. Next. So why it is very complex? Next slide, can you go? There are multiple mission paths are there to reach moon and land. So first is we have to cross the atmosphere. So we have a launch vehicle. Launch vehicle will inject the spacecraft into a precise orbit. From then on, we have to bring the moon closer to the spacecraft. So we have to use our own propulsion system, spacecraft propulsion system, to use to raise the orbit and come closer to the moon, and again insert into the moon, and finally reduce the elliptical orbit to circular orbit. And then there is a conducive environment for a landing. So the mission design is to optimize the number of maneuvers right from launch till landing. So these are the various phases you would have seen during the journey of Chandrayaan-3. So I am not going to dwell on it. Next. But the most important thing is, as I told, the launch itself is very complex. We have to see that unlike other missions, we have a specific launch window. Typically, it falls twice in a year because we have to land onto a particular targeted landing site. So that puts a constraint that when we have to launch. Similar way, as I told, there are various maneuvers which needs to be performed because even though the space is, we call it as no gravity, but still there are various perturbations coming from Earth, Moon, solar radiation pressure, and also we have to cross the Van Allen radiation belt for which the electronic components have to survive. All these hurdles are there. And finally, once we reach the Moon, once we start the power descent, as you know, the Moon has no atmosphere. It is full of vacuum. So we cannot use any parachute to kill the velocity. So we have to have a controlled propulsion system to break the velocity. You know, we are starting from 0 meter per second at Earth and almost 11 kilometer per second when we are leaving the Earth, and again capturing the Moon of about 2.4 kilometer per second. Then when we start the power descent, it is around 1.68 kilometer per second. Now we have to bring it down the speed to 0 meter per second to the targeted landing site. So that throws a lot of challenge. So every system has to work in unison. We have various systems like navigation, propulsion, guidance, control, and various other systems are available which all have to work in unison. And as you know that landing day we had a 19 minutes of autonomous landing sequencer wherein all the intelligence have been built to take real-time decision. If anything goes wrong, it has to detect that failure and it has to overcome the failure. So all this intelligence have been built. And finally, when we just before the landing, even though we know that the landing site is thoroughly characterized by our camera, but still there are a lot of uncertainties in terms of boulder height. So we need to avoid the obstacle. Like how we have got 2 legs, similar way lander has got 4 legs. And these legs have to absorb the strength, it has to withstand the strength, and it has to offer the stability. So at the time of landing, it should not topple. So for which all these systems have been thoroughly characterized in ground, simulating the Moon environment. So Moon has got a different environment. One is there is no atmosphere. Because of that, the temperatures are it is very extreme. When the sun is there, it goes to as high as 150, 160 degrees centigrade. When sun is not there, it goes to very low temperature like minus 150 degrees centigrade. And also the gravity is different. You know that Earth has got 9.81 meter per second square gravity. Whereas in Moon, it is 1/6 of Earth's gravity. So these are the fundamental changes because of which we need to thoroughly characterize the systems on board lander. So we created a number of test beds, number of test cases, number of test platforms to characterize the systems to get confidence before the launch itself. Next slide. So this is something Chandrayaan-2, we all know that Chandrayaan-2 was very successful, orbiter went very well, and all these mission phases have gone through. We already got a good handle before the Chandrayaan-3. Next slide. So this also is already covered by Narayanan sir. I will not dwell on it. So during this phase, we had a crash landing. So the dotted line is where we got the result, and whatever the red color line is what is expected. So at the time of touchdown, we were nearly 50 meter per second in vertical and horizontal direction. So no way our legs can withstand or any system can withstand. So it is all designed for very low velocity. Next slide. So to overcome that, first, there are 5 important points in Chandrayaan-3 we have taken care. First is, whatever the Chandrayaan-2 heritage was available, which has been thoroughly utilized. Then the on-orbit experience, whatever the failure analysis, in fact, the failure analysis committee chairman was Narayanan sir, and all these failures have been thoroughly addressed, root cause was identified, and we have come up with a corrective action. That was the second point. The third point is, Even though the corrective actions are in place, but still there are a lot of improvements made in the lander, both hardware as well as software. There are a host of improvements we have made to autonomously handle wider ranges of dispersions to achieve the safe and soft landing. And the fourth important point is the ground test. So we did lot of ground test and the simulations compared to Chandrayaan 2 to thoroughly characterize the systems to get confidence. And the fifth one is on-orbit characterization. Before the actual power descent, there are various systems have been tested thoroughly to understand the systems so that we are very clear for that 19 minutes of power descent. So this all led to the safe and soft landing. These are the 5 important points which happened in Chandrayaan 3. Next. So these are all everything is available in internet. So I will not dwell into it. The launch vehicle is used, the heaviest launch vehicle. We had 3 module, propulsion module. As you all know, it has taken the lander to the final orbit. Rover was kept inside the lander. Upon landing, the rover was deployed. And we had 3 important objectives: safe and soft landing, rover roving on the moon surface, and conducting the in situ scientific experiments. We have got totally 6 payloads, 3 in lander, 2 in rover, and 1 in propulsion module. Next. And these are all the phases which, like Chandrayaan 2, we have used. But the power descent phase is one of the important thing. Even though Chandrayaan 2 has got 2 phases, one is nominal and contingency phase, but this time we have inbuilt with many phases. Multiple mission paths have been built in. If one thing goes wrong, but still our aim is to have a safe and soft landing. That was our target. So towards that, we built many mission paths. But fortunately, we have a perfect nominal landing. And our site was, the landing site was 69.3 degree latitude towards south. We were the first to go near to the South Pole, and 32.34 degree towards east. For every orbit, we had a backup plan. Right from launch onwards, till the landing, we had a backup plan. In case, for example, the prime landing site, if you would have missed, we would have taken an alternate landing site, which comes into the west direction after 3 days. For some reason, 23rd August, if landing would not have happened, we would have landed on 26th August. Not on the east side, we would have landed on the west side. Next slide. And these are all the various important, the improvements have been made, which is very technical, so I will not dwell into it. Next slide. And just to give a quick glimpse, there are in the lander, the blue color indicates that all the improvements, and the green is totally new, and the black one is the heritage systems, which means almost all the systems have been improvised. One new additional thing is the laser Doppler velocimeter. This gives a velocity information. You know that in moon we don't have a GPS. For us to land safely to the targeted point, we need to know where we are. The lander needs to know its position as well as velocity. We call it as a state vector. All the x, y, z direction, x dot, y dot, z dot needs to be known at every instant of time for us to guide to the correct point. So in the absence of GPS, we need to have a terrain relative navigation sensors. We had a host of sensors which gives position information, velocity information. For the velocity information, we built on our own a state-of-the-art instrument. This is called laser Doppler velocimeter, which gives all the 3-axis velocity information. Next slide. Next slide, please. So these are the 3 important tests we conducted. One is using an helicopter as a platform to get correct velocity and altitude. We characterize the sensors and navigation system. Having characterized that, we have put propulsion system in closed loop, for which we created another platform and another test site at Sriharikota. That is called integrated odd test. And finally, at the time of dropping, the legs has to withstand the strength as well as offer the stability, for which we conducted a host of tests simulating a combination of vertical velocity and horizontal velocity on a flat terrain, on a slopey terrain, on a hard surface, on a soft surface. Likewise, we created a lunar soil simulant test bed and did a host of tests. These are the 3 important tests we did in the journey of Chandrayaan 3. Next slide. And these are the photograph of the flight modules on the left side, propulsion module, lander and rover. On the right side, the special test modules. And the center one is the integrated module of Chandrayaan 3. Next. Next slide. Next slide, please. This is some of the glimpses of the satellite readiness at Sriharikota. Finally, the heat shield is assembled. Next. Next slide. And this is how the launch took place. Next. And these are the various mission phases like Earth phase, lunar, translunar injection, Mars acquisition, then the actual power descent phase. Next. And this is one of the camera visual coming from the spacecraft to Earth for every 3 seconds. A portion of the lander and portion of the moon surface was it was visualized. Even though the critical parameters was available with us during the landing time, but this is something, an image we got during the landing every 3 seconds is something, seeing is believing. So we were actually getting this live stream image during the landing. You can go to the next slide. Next slide, please. This is upon the landing. You can click that center one. Previous slide. Okay, you can go to the previous slide and click center. So once the lander landed, the ramp has to be deployed because the rover is vertically placed inside the lander and the rover has to come out of the lander. These are all the animation, whatever you are seeing now. But now this is an onboard camera visual coming live. Once the lander landed, this you would not have seen because after the landing we did not have a live coverage, but we were working in that night to take the rover out. Next slide. And this is how the lander looks on the left side. So all the time we used to see the other landers, but our own lander, we took a picture from the rover camera. The rover has 2 cameras. This camera has took a picture of lander with 30-meter distance. And that on the right side you can see the ISRO, our Indian flag mounted on the rover backside. At the rear side of the wheel we had a national emblem as well as the ISRO logo that also was captured by lander camera. Next slide. And this is some of the important pictures. Not only the lander was captured by rover, also lander has got a scientific instruments. One instrument has to be deployed inside the lunar regolith. That is called a probe. That probe also was taken, the picture was taken. And another instrument was a seismic activity instrument that also was dropped onto the surface. So that picture also was taken by rover camera. Next. And this is how the rover traversed from where the lander landed. We almost had a 101 meter mobility for 24/7 for the 14 days of mission life. So the rover had lot of challenges compared to lander because lander was autonomously landing, whereas rover has to be work in a semi-autonomous way. The rover cannot communicate directly with Earth. It has to communicate via lander. So the entire operation was semi-autonomous way. We need to see that in front of the rover there is no obstacle. So we need to take the image, study at ground, and we have to move from point A to point B and again operate the scientific payloads. This goes on for 24/7 for the entire 14 days. So this is how we did. In fact, it was phenomenal. We did many collection of scientific payload data from rover, which has also detected various minerals and including sulfur. Next. And this I will not go. See, there are various, our objectives are very clear. It is not only for landing and roving. We had a scientific objective. The scientific objective is Chandrayaan-1 as basically it's a remote sensing payload. There were many instruments. So Chandrayaan-2 has got a 2 objective. One is orbiting and landing. The orbiting payloads, all are high resolution payloads compared to Chandrayaan-1. For example, if you see the TMC-1 which was in Chandrayaan-1, which had a resolution, very poor resolution. Whereas in Chandrayaan-3, we had an orbiter high resolution camera, which has a 0.25 meter, 0.32 meter resolution in nadir direction, which is the best available globally. Similar way, IARS payload, which detected hydroxyl, water, and the water ice regions unambiguously. Likewise, we had various instruments like Minisar, we had S-band, whereas DFSR, we had both L-band and S-band. So Chandrayaan 2 was a advanced version of payloads compared to Chandrayaan 1. Next. Now, from Chandrayaan 2 to Chandrayaan 3, Chandrayaan 2 basically it was a global measurement. Again, it's a remote sensing payload. Chandrayaan 3 is basically an in situ experiment. This we did not have an opportunity during Chandrayaan 2. So once the Chandrayaan 3 landed, we operated all the 5 payloads which are complementary in nature. For example, if I take an example of DFRS, which is confirming the, which was giving both L-band and S-band all the polarimetry data. Whereas here you will get the near surface plasma experiment. Likewise, we had a seismic activity, then the thermal probe which gives a temperature measurement within the regolith as well as the thermal conductivity. Like we had a alpha particle X-ray spectrometer and laser-based induced spectroscopy, which detects major and minor rock forming elements. There are various elements which detects. So these all are complementary to the remote sensing payload, which confirms that our data are correct. Next. So this is something which I already told. These are the first get data. We have got various detection of minerals from the 2 spectroscopy payload in the rover. One works on the laser-based principle, another works on the extra fluorescent technique. Then the surface plasma experiment is first ever state-of-the-art payload which measured the electron density and temperature. And this is a very important information for the future radio wave communications, how it is affecting the lunar surface. All these things we have got plenty of data from this payload. Next. And the seismic activity, the various, this has got a high sensitive accelerometer which detects the natural seismic activity as well as the artificial seismic activity. During the course of rover mobility, the payload deployment, all these artificial events were captured by this instrument, as well as one natural seismic activity also was captured. And thermophysical property, as I told, we have got a very strong vertical gradient of temperature in the lunar regolith. We had up to 140 mm we have drilled inside the lunar regolith, and we had 10 sensors, and every sensor has captured the temperature measurement as well as the thermal conductivity. Next slide. And this is some of the glimpses. We can skip this. Next slide. Next slide. Next. You can click that video. Whatever I explained, some 5 minutes video is there. You can watch. You can open the folder. You can put the sound.
Project life cycle, out of which 3-way flight modules and 3-way special test modules. A test module called the ICT module was realized after integration. Detailed IST, sensor level alignment and EMI/EMC tests were also carried out before shipment to ASTE Bangalore. At ASTE facility, the ICT module was integrated onto the helicopter in the underbelly cutout area, and this cutout acted as a viewport for all the sensors during the test. The helicopter was further ferried to Chitradurga, where the ICT tests were conducted in a campaign mode. A comprehensive module was realized for conducting the test by accommodating all essential systems. A new facility was realized at SDSC Shar for conducting the IHT, craters and boulders simulating hazards during landing. A total of 20 tests were successfully conducted, which include 6 dry runs, 8 static tests and 6 dynamic closed-loop tests. The lander leg drop tests were carried out to evaluate the energy absorption capability, strength and stability aspects of lander legs during touchdown on flat and sloped surface and on lunar soil simulant and hard surface. A total of 15 drop tests at simulator level and 2 drop tests at QM structure level were conducted successfully. Detailed assembled mode IST was carried out, followed by mass property measurement, thermo-vacuum test, solar panel assembly and illumination tests, EMI-EMC test at CATF eyesight. This was followed by pre-dynamic deployment of secondary rover RAM, primary RAM and rover rollout from lander and payload deployments such as ILSA and Ramba, chased, and the lander was made ready for further activities. A 6-wheeled rover is accommodated inside the lander. Rover solar panel deployment and illumination test, rover standalone EMI-MC test, vibration test, thermo-vacuum test, and mass property measurements were carried out. All tests associated to rover were successfully completed and the rover was made ready for further integration onto lander. Chandrayaan-3 spacecraft was made ready for shipment to spaceport at SDSC Shah.
Lander module will get separated with a relative velocity of approximately 1 meter per second.
like to close by telling these few words to students. See, Chandrayaan 3 is an example of resilience. See, we have bounced back from Chandrayaan to failure. So failure is a stepping stone for the success, and we should not worry about failure. Making an attempt is more important. So it's okay to fail. Please put yourself out 100%. You involve yourself. That will lead to a success. This is what I just wanted to share it with you. Thanks for the opportunity given.
बहुत बहुत धन्यवाद सर आपका। आपने चंद्रयान 3 के बारे में डिटेल में बताया। ये सारे बच्चे जरा इधर ध्यान दें। अभी आप लोग में से कितने जो हैं चंद्रयान 5 का हिस्सा बनना चाहते हैं? बहुत कम लोग हैं। चलिए, गुड, वेल डन। अभी आपके समक्ष अगले जो वक्ता आएंगे वो उनने 26 साल मद्रास हाई कोर्ट में वो लॉयर रहे और 7 साल से जज हैं और अब वो जस्टिस मद्रास हाई कोर्ट हैं। डॉक्टर जी.आर. स्वामीनाथन अभी आपसे बात करेंगे, आपको समझाएंगे कि किस तरह मेहनत जो है एक अकेला रास्ता है आगे बढ़ने के लिए। सर।
Good evening to one and all. Kindly excuse me. I do not know Hindi. I have to speak in English, but I'll be very brief. I request all of you to lend me your ears for the next 15 minutes, 1-5. You will be able to follow me, I'm sure about it. I must first express my deepest gratitude to Swami Dharmabandhuji for one very important reason. See, to me, the true heroes are not Shah Rukh Khan, Salman Khan or Amir Khan, Ranbir, no, not they, but Veeramuthuji, Radha Krishnanji, Dr. Narayananji and Somnath. They are our true heroes. For bringing them here, for giving me this opportunity to share the dais with these great persons, true heroes of India, I am grateful to Swamiji. I am truly grateful to him. I just want to make 5 or 6 short points. My young boys and girls, dear friends, closely follow me. You will be able to. Organizing this Shibir once may be possible, but organizing it year after year, consistently, is not a small thing. I request all of you to note down one name, the name of the author and the book also, Malcolm Gladwell. Malcolm Gladwell. The name of the book is Outliers. What outliers? What he says is, you need to do something consistently for 10,000 hours. Of course, in the right manner. Then you are bound to become a genius, an expert. So the first take-home message for you from this camp is, have one single thought, pursue it, and as Veeramuthuji rightly said, you may fail at some point of time. No, but don't give up your heart. Learn the lessons. In fact, I was told by Dr. Radhakrishnan that Dr. Narayanan was the chairman of the committee that was constituted to go into the reasons why Chandrayaan 2 mission failed. They learned the lessons. And as Veeramuthuji was repeatedly saying, that shows the resilience of the Indian spirit. Therefore, consistently do something. All of you are bound to become experts, genius in your field. And the first book that I recommend for you to read is Malcolm Gladwell's book, Outliers. Point number 1. Point number 2. Friends, I am basically a lover of books. And whatever book I am presently reading, only from that book I will be narrating an anecdote or two. Right now I am reading a book by name, it's in Tamil, therefore I will not say that. It's by one Mohan. Mohan is an important writer in Tamil, a critic. But he entered the Tamil literary scene as an editor. All of you know the meaning of the term editor? When we see the movies, first the name of the hero will come, then heroine, then towards the end, director, producer, etc., music director, etc. In the middle, there will be one slide, editor. Who is an editor? What is his role? His role, in literature also, we have literary editors. Their job is to make the text better so that it becomes readable, accessible. To make the text a better copy. So I feel this camp plays the role of an editor. All of you have come with certain personalities. But when you leave this camp, you become a better version of yourself. So I look at this camp more as playing the role of an editor. For that also, I must express my gratitude to Swami Dhanobandhuji. See, from Mohan's book, it's about important Tamil personalities. He has written about a number of persons. Of them, I will refer only to 2 persons. My young friends, please make a note of these 2 names. The first name is Ananda Kumarasamy. Please note, when you return to your room this evening, Google this name, Ananda Kumarasamy. Ananda Kumarasamy, he was born to a Sri Lankan person. His mother was an Irish woman. And he died before, in 1945 or so, before India got independence. What did Ananda Kumarasamy do? The most important thing, a role played by him was to make us proud of our culture. See, till then, the Western people, our British masters, they were looking down on our culture, our music, our dance, everything, our sculpture, our arts. It was Ananda Kumarasamy who did extensive research and wrote book after book, essay after essay, highlighting the glory, the greatness of the Indian culture. Time and Eternity, Dance of Shiva, so many books he has written. Of course, it will be a little difficult for you to understand. You can read them maybe after 10 years or so, but you must read the life of Ananda Kumarasamy. It was he who made us proud of ourselves, our heritage. The next name I am going to mention is Joseph Cornelius Kumarappa. We fondly call him as J.C. Kumarappa. He is a forgotten name. But I request each and every child here, student here, to go to the library and read about him. J.C. Kumarappa. J.C. Kumarappa was an auditor by profession. He had his education in UK, in USA. And he hailed from a very elite family, very rich family, great background. Then he comes in contact with Mahatma Gandhiji. And that meeting turned out to be a turning point, a transformation moment in his life. And Kumarappa became a greater Gandhian than Gandhi himself. Friends, I request you to read his book, Economy of Permanence. Please make a note of it. Economy of Permanence. He talks about the village development, sustainable development, how march of technology at the cost of human beings, all those things he says. He was such a great person. See, in fact, I'll narrate only one anecdote from his life, what a great person he was. He was made in charge of Bihar Earthquake Relief Fund auditing. He was so busy with that work. Suddenly, Mahatma Gandhi comes to Patna. He wanted to meet Kumarappa. He sends word, Kumarappa, come and meet me. Kumarappa says, no, you have not got an appointment with me, and I am really busy with this auditing work. For the next 3 days, I can't meet anybody. And he said, Mahatma Ji, I can't meet you. He sends him away. He had such a person, great person. When India got independence, J.C. Kumarappa was given big offices. Whatever post you want, you take it. Kumarappa said, no, I don't want anything. He led such a simple life. he came back to a place near Madurai where he spent the last days also. And why I am mentioning Kumarappa's name is, we must be idealists like him, totally dedicated to the cause of the motherland. Friends, I request all of you to kindly go to the library and read about these two great men, Ananda Kumarasamy and, what is the other name I said? I must hear. Kumarappa. Tell me. Yes, Kumarappa. A very great person. Right. Now I will mention another name. In fact, that is a book I am reading. Of course, as a sitting judge of the Madras High Court, I do not know how far I am justified in making a reference to this name, particularly when there are so many police personnel here. But I can't help making a reference to that. I am now reading a book from the Pansi Yard, P-H-A-N-S-I, Pansi Yard by Sudha Bharadwaj. Sudha Bharadwaj was arrested. She was in Yerawada jail and she is still facing prosecution. She has been labeled as a Maoist and she is facing great. And she has written about her jail experiences. I don't want to talk about her ideological convictions or about her case, which I am not supposed to do. But about Sudha Bharadwaj, I want all of you to know one thing. Her parents were great economists. She came from a very, very, very good, highly educated background. She studied in UK. It so happened that she was born in USA when her parents were doing their studies. And as per US Constitution, anybody born in US soil is automatically an US citizen. And Sudha Bharadwaj comes to India, and when she turned 21, she decided to dedicate her life for the cause of the working laborers. And friends, I have been in Madras till 2004, now I am in Madurai. In Madras, near the Gemini Bridge, you have the US consulate. Whenever I cross that place, I'll see a long queue. People will be waiting for morning 4 o'clock for getting US visa from the American embassy. And this Sudha Bharadwaj goes to the American embassy and says, I don't want American citizenship, I want to renounce my American citizenship. Imagine, who will do that? And then she goes to Chhattisgarh. Let us not go into those aspects. But the point I want to make is, here you have a person highly educated. She studied in IIT. Our Dr. Narayanan did his IIT Masters and PhD in Kharagpur. Sudha Bharadwaj did her IIT for 5 years in IIT Nagpur. Hailing from such a background, she gives up everything and goes and serves the cause of the working persons in Chhattisgarh, that iron ore mining areas and all. Why I am saying this is, unless we have the sense of idealism, a dedication to a cause, willingness to sacrifice. See, the scientists who are now sitting on this dais, see, they must have sacrificed hours and hours. Dr. Narayan was telling me this morning when I was coming with him, when Chandrayaan-2 mission failed, our Prime Minister Narendra Modi ji said, you will find out the cause and give me a report in 30 days. Normally, such an analysis will take months and months. They say the team members slept for hardly 3 to 4 hours a day. And on the 30th day, they are able to give their report. See, unless they must have sacrificed their sleep also during that time. See, unless we are ready to sacrifice, come out of our comfort zone, it is not possible to serve the nation. Why I refer to Ananda Kumarasamy, J.C. Kumarappa and Sudha Bharadwaj? Why I said that? See, before me, the three scientists spoke to you about the space program, everything. I come from the law background. I am a judge. So at least for 2 or 3 minutes, I must tell you something about law. And now I'll link up why I refer to those three great individuals. There are several branches of law. I will now draw your attention to only one branch, environmental jurisprudence. civil law, criminal law, taxation law, constitutional law, so many laws are there. But I will talk to you for a few minutes about environmental law alone. Friends, they said no, we sent our satellite or something to USA, and in that USA we sent our constitution book also. You said no? That's what he said. Am I right? Ah, yes. See, that constitution is the most fundamental of all books. It sets out the guiding arrangement for the country. See, this constitution was not written in one day. A group of very eminent thinkers, great persons, headed by the great Dr. Ambedkar, almost for 2.5 years they deliberated. And then in 1949 November, this constitution adopted. And from January 26, 1950, it came into force. Friends, interestingly, for those 2.5 years of deliberation, not one person spoke about environment. Not one person. And in the entire constitution, there was not even a single provision regarding environment. It was only in 1975-1976, Prime Minister Indira Gandhi introduced two provisions in our constitution. Article 48A and Article 51A bracket G, fundamental duties and directive principles. Only by virtue of these two provisions introduced by Prime Minister Indira Gandhi, the constitution began to think about environment, the need to protect forests, lakes, wildlife, everything. And 1985 onwards only, our Indian Supreme Court began to deal with environmental cases. Now, Article 21, that's one of the most important provisions of the Constitution. And in Article 21, the most important judgment is Maneka Gandhi. Please make a note of this judgment also. Maneka Gandhi judgment in 1978. Maybe 10 years later you will read. See, just as my eminent three predecessor speakers, maybe they spoke many things, much of it went above your head. But it's good that it just enters, you hear it at least, so that when the time comes, you will feel reminded of those things. And our Indian Supreme Court has evolved the environmental jurisprudence like anything. And now, in these days of climate change, environmental issues, these jurisprudence, these things will come to our rescue. We can make use of it. But then, for everything, courts and judges cannot be interfering. See, now I am coming from Tamil Nadu, and Tamil Nadu has been battered by floods. And at least 1 or 2 districts have been terribly affected. And what is the reason for all that? Because of the way we have organized our entire lives. See, recently, I was listening to one lecture by a very eminent retired IAS officer by name Thirupugal. I was told he was some chief secretary rank in the state of Gujarat only, Thirupugal. He spoke so brilliantly. And only one point which he made, I will now bring it to you. He said, we want some small thing, maybe for 100 grams, some small article. We order through Amazon. And it comes in almost not less than 300 to 400 gram packaging, plastics, so much of wastage. So like that, most of our lives is so full of wastage. And unless we internalize some very important values, in fact, the purpose of organizing a camp like this is only that. We need to internalize so many values. And only then, all of you can become true environmental warriors. And in this age of climate change, extreme weather conditions, we need hundreds and thousands of environmental warriors. And I'm certain that each and every one of you will become one such warrior. And that is why, and you will, when you will become such warriors, only when your heart is full of idealism. And when you will have idealism, only when you read the lives of Ananda Kumarasamy, J.C. Kumarappa, and Sudha Bharadwaj. That is what I strongly feel. Friends, when our scientists were putting out that video, when that rocket, with full blast was going up, it was such an awe-inspiring sight. I am certain by being here, by imbibing the ambience here, I am certain that you will cultivate certain very fundamental values, And as a result of cultivation of those fundamental values, I am certain that your lives also will go upwards, like it will blast like a rocket, and you will achieve great success in your lives. And I wish you all the very best. And I once again express my gratitude to Swami Dhanobandhu for giving me this opportunity. Thank you very much.
Thank you so much, sir, sparing your valuable time. I am grateful here. प्यारे बच्चों, आप सब लोग शांति रखेंगे। मैं अपने साथी ब्रिगेडियर ज्ञानोदय सर से रिक्वेस्ट करता हूं, सर, ऑनरेबल मिस्टर जस्टिस जी.आर. स्वामीनाथन सर का शॉल सोफा तो पहनाकर आप सम्मान करेंगे। बुके हैं फूल का, वो बुके कहाँ गए? सब बोले क्या हो? सब फूल माला भी थे ना? ऑनरेबल डॉक्टर बी.एन. रामाकृष्णा सर का सम्मान। ब्रिगेडियर साहब प्लीज़ कम। डॉक्टर बी.एन. रामाकृष्णा, नारायण सर प्लीज़, अच्छा प्लीज़ कम कोई नो इशू सर। ऑनरेबल डॉक्टर रामाकृष्णा सर का सम्मान। ब्रिगेडियर साहब प्लीज़। ऑनरेबल डॉक्टर वीर मुथुवेल सर का सम्मान। ब्रिगेडियर साहब प्लीज। ऑल टीचर्स, स्टूडेंट्स, सभी लोग स्टैंड अप होकर के क्लैंपिंग करेंगे हमारे ग्रेट साइंटिस्ट एंड ऑनरेबल जस्टिस के लिए। सभी लोग एक बार खड़े होकर के अपनी जगह पर सबके लिए ऑनर करेंगे। ये हमारी कंट्री के रियल हीरो हैं। इनके लिए एक बार बोलेंगे भारत माता की, भारत माता की। थैंक यू सर। प्यारे बच्चों, विश्राम, सावधान, राष्ट्रगान प्रारंभ। जनगण मन अधिनायक जय, भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठ, द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा, उज्ज्वल जलधि तरंगा। तव शुभ नामी जागे, तव शुभ आशीष मागे, गाही तव जय गाथा, जनगण मंगलदायक जय, भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 जय। भारत माता की, भारत माता की, भारत माता की। जय हिंद, जय हिंद, जय हिंद। थैंक यू।